Hello guys, so today we are going to wind off our series on Combined Science Paper 2 that was written in November 2020. We are going to revise from number 13 to number 15, but in the final exam, candidates are required to answer in 2 questions on the separate answer sheet provided. Number 13A is reading, explain how a positively charged gold leaf electroscope can be used to test the charge on a charged rod. 4 marks. So first I'm going to explain what is known as electroscope. It is a device that is used to detect the presence of charge. So this is what happens in order to test for the charge using electroscope. The board is to be detected is brought close enough to metal knob. When a charged object touches the knob at the top of rod, the charge flows through the rod onto the leaves. Both gold leaves will have the same charge and hence they will repel and diverge. Degree of divergence is an indicator of the amount of charge. That is, the more the charge, the more will be the divergence. So if leaves come close to each other, the charge of a non-board is negative. Let me repeat to explain again. Electroscope is a device that is used to detect the presence of a charge. The board to be detected is brought close enough to metal knob. When charged object touches the knob at the top of the rod, charge flows through the rod onto the leaves. Both gold leaves will have same charge and hence they will repel and diverge. Degree of divergence is an indicator of the amount of charge. That is, the more the charge, the more will be the divergence. If leaves come close to each other, the charge is going to be negative. Let us move on to B, part 1. We are supposed to describe how a house is protected by a lightning conductor. This is not the first time for me to see this question. I've seen it in several question papers, so you should master this question and be able to answer it. A lightning conductor protects the house from lightning by allowing the current to travel to the ground rather than through the structure. Current in the conductor may be so high in the event of direct lightning that it melts or evaporates to metal, but the damage to the building will be minimum. So lightning conductor carries the charges to the ground, preventing them accumulating on the structure. That is how it protects the house from lightning. Let me explain again how lightning conductor protects house from lightning strikes. So lightning conductor protects the house from lightning strikes by allowing the current to travel to the ground rather than through the house. Current in the conductor may be so high in the event of direct lightning strike that it melts or evaporates the metal, but damage to the house will be minimal. So lightning conductor carries charges to the ground, preventing them accumulating on structure, thereby protecting the house. Let us move on to B, part 2. We are supposed to state any 2 dangers of lightning. So lightning strike can result in cardiac arrest at the time of injury. It can also cause fire and destroy the buildings. It can also destroy electronic equipment such as TVs and computers. And then on B part 3, we are supposed to state N1 safety precaution that should be taken against lightning. So we should immediately get off elevated areas such as hills and mountains. We should never lie flat on the ground, and then we should never shelter under isolated tree. This was the complete solution for number 13. I've repeated to explain number 13A and number 13B part 1. Maybe I'm going to just summarize on B part 2 and B part 3. On B part 2, we're supposed to state N2 dangers of lightning. Lightning strikes can result in cardiac arrest at time of injury. It can also destroy electronic equipment such as televisions and computers. It can cause fire and destroy buildings. And then on B part 3, we're supposed to state N1 safety precaution that should be taken against lightning. So we should immediately get off elevated areas such as hills and mountains. We should never lie flat on the ground, and we should never shelter under isolated trees. So we now need to move on to number 14. Number 14A, Fig 14.1 shows a model of a hydroelectric power station designed by a student. On number 14A part 1, we are supposed to describe using energy changes how the bulb in the model lies. So we are having this water in the water reservoir. It has a potential energy. When it is going to flow from this water reservoir going to this tubing, the potential energy is going to be converted into kinetic energy as it falls through water reservoir. And then at this point, the kinetic energy of water is converted into mechanical energy as it turns the tubing blade. And then on this mounted generator, we are going to have mechanical energy being converted into electrical energy as it spins the generator. And then for the bulb to light, electrical energy is then converted into thermal energy as it passes through the filament in the light bulb, causing it to heat up and emit light. Let me repeat again to explain number 14A part 1. We are supposed to describe using energy changes how the bulb in the model lies. The potential energy of falling water is converted to kinetic energy as it falls through the water reservoir. And then the kinetic energy of water is converted into mechanical energy as it turns the tubing blades. Mechanical energy is converted into electrical energy as it spins the generator. And then finally, electrical energy is then converted into thermal or heat energy as it passes the filament in the light bulb, causing it to heat up and emit light energy. Let us move on to number 14A part 2. We're supposed to explain why using a hydroelectric power station is better than using a thermal power station. It is better to use the hydroelectric power station because it requires no fuel, as water is used for the generation of electrical energy. Hydroelectric power station is quite neat and clean as no smoke or ash is produced compared to thermal power station. Hydroelectric power station is a renewable source of energy as it requires very small running charges because water is source of energy which is available free of cost, while least thermal energy is non-renewable source of energy. Let us move on to B, part 1. We are supposed to state the relationship between voltage and current. You should know that current is equal to voltage over resistance. The chemical symbols that are used is I is equals to V over R. This tells us that the current flowing through a circuit is directly proportional to voltage and inversely proportional to resistance. If we increase voltage, current is going to increase. If we increase resistance, current is going to decrease. And then on B, part 2, we are supposed to state N2 factors that affect resistance of an electrical conductor. So we have material length, cross-sectional area, and temperature. I'm going to explain each of them, but in this question, we are just supposed to state the explanation is not needed. Let me explain why material length affects resistance. The longer the conductors, the more the resistance. And then the larger the cross-sectional areas, the more the resistance is going to be reduced. And if temperature increase in conductors, resistance is going to increase and it is going to decrease in semiconductors. And then on B, part 3, we are supposed to calculate the current flowing in a circuit if the potential difference across a 2 ohms resistor is 6 volts. So we are going to use this formula. Current is equals to voltage over resistance. We are told that the voltage is 6 volts, and then the resistance is 2 ohms. If we say 6 volts divided by 2 ohms, we are going to obtain our current as 3 amperes. Make sure that you don't forget the units. They are very, very important for you to obtain all the marks. This was the complete solution for number 14. I'm going to summarize the answers. On number 14A, we're given a model of a hydroelectric power station designed by a student. So we're supposed to describe using energy changes how the bulb in the model lights. So the potential energy in water is going to be converted to kinetic energy when it flows from the water reservoir, and then the kinetic energy is going to be converted into mechanical energy as the tubing blade is going to turn, and mechanical energy is converted into electrical energy as it spins the generator. Electrical energy is then converted into thermal energy as it passes through the filament in the light bulb, causing it to heat up and emit light. And then on part 2, we're supposed to explain why using a hydroelectric power station is better than using a thermal power station. Hydroelectric power station requires no fuel as water is used for generation of electrical energy. It is quite neat and clean, so no smoke or ash is going to be produced. Hydroelectric power is renewable source of energy. It requires very small running charges because water is source of energy in which is available free of cost. And then on B part 1, we're supposed to state the relationship between voltage and current. So current is equals to voltage over resistance. And then on B part 2, we're supposed to state N2 factors that affect resistance of an electrical conductor. So we have material length, we have cross-sectional area, and then we have temperature. And then finally, on part 3, we're supposed to calculate the current flowing in a circuit if the potential difference across a 2 ohms resistor is 6 volts. So in order to calculate current, we say voltage over resistance. So we are going to say 6 volts over 2 ohms in order to obtain 3 amperes. So you should make sure that you include the units for you to obtain all the marks on number 14. Let us move on to the final question, which is number 15. Number 15A, a pot with water is placed on an electric stove and the water is heated until it boils. On part 1, we are supposed to state the modes of heat transfer involved. So we have conduction and convection. And then on number 15A, part 2, we are supposed to describe the modes of heat transfer stated in part 1. When pot is placed on stove to boil, conduction heat warms up the pot, which heat the water molecules inside the pot. As these molecules heat, convection causes them to move away from the interior of the pot as they are replaced by the cooler molecules. Let us move on to number 15, part B. It is reading, the electric stove is marked 2000 watts. Define the terms electrical power and electrical energy. Electric power is rate per unit time at which electrical energy is transferred by an electric circuit. Electrical energy is a form of energy caused by movement of electric charges or electrons from one point to another. Let us move on to B, part 2. The water in the pot boils after 8 minutes. Calculate the energy supplied by the electric stove. So we should understand the relationship between energy, power, and time. Energy is equals to power times time. So we are going to say our power is 2000 watts and our time is 8 minutes. Energy is supposed to be given in kilowatt hours. So we need to convert 2000 watts into kilowatts. We divide 2000 by 1000 in order to get 2 kilowatts. And then our time needs to be in hours. So we are going to say 8 over 60. Let us punch on the calculator 2 times 8 over 60. We are going to obtain 0.2666. So we write 0.267 kilowatt hours. This was the complete solution for number 15. Number 15A, we're supposed to give the modes of heat transfer that are involved when a pot with water is placed on electric stove and water is heated until it boils. We have conduction and convection. And then on number 15A, part 2, we're supposed to describe the modes of heat transfer stated in part 1. So when pot is placed on stove to boil, conduction heat warms up the pot, which heats water molecules inside. As these molecules heat, convection causes them to move away from the interior of the pot as they are replaced by the cooler molecules. And then on number 15, part B, we're supposed to define electrical power and electrical energy. Electrical power is the rate per unit time at which electrical energy is transferred by an electric circuit. And then electrical energy is form of energy caused by movement of electric charges or electrons from one point to another. And then we're supposed to calculate energy supplied by electric stove if the water in the pot boils after 8 minutes. So the formula of calculating energy is power times time. Our power needs to be in kilowatts, and then the time needs to be in hours. So we are going to say 2 kilowatts times 8/6 in order to get 0.267 kilowatts hours. This marks the end of our tutorial today on physics section that was in November 2020. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like, and share my videos. I love you all. This is Eve signing out.